All right, so yeah, let's talk about the ODPs. So what was the last one? 210?
Yeah.
All right, so yeah, we were doing the insert. So 210, we have a list of two nodes that were given. And we're asked to create a new node and insert it between the first and second. So we're given a pointer, so we have to make a new node, so we got to call malloc. Right, malloc's how we get a new chunk of memory to do stuff with. So we call malloc size of struct node, calling that temp, set the data field equal to the number. So that sets the upper part of this new node. And then the next field, which is the thing this new node is going to point to, I set that to pointer next next. So let's do our famous pictures. Here's pointer. Here's some node that it's pointing to. And there's potentially other stuff. Is this true? Oh, we're inserting between the second and the third. Okay. So this goes here, this goes here, this may go here, and it may go on, or it could be the end of the list or something, but there's at least 3 nodes. And we're creating a new node that we want to put in here. So temp is the new node, right? We call malloc and we set temp data equal to num. So this is temp, and it's got a data value of num. And so to put it in between the second and the third, we've got to do 2 things. We have to make this thing point to the third node, and then we have to make the second node point to the new thing. Right? So this node is pointer. This node is actually pointer arrow next. And this node is actually pointer next, next. You could do this with some temporaries if you wanted, but you can also one-line it. So this red connection could be something like num next equals pointer next next. All right, so that's this line right here. Temp next equals pointer num next, pointer next next. And then the blue line is pointer next equals temp. Right. So this block is pointer next. The thing that it points to is pointer next next. So when you say pointer next next equals temp, you're saying this block's next field should point to temp. That sets up the blue arrow. Again, the wording is potentially ambiguous / confusing because pointer next next is this node, but it's actually the next field of this node, right? So when I say pointer next next equals temp, I'm not changing what this block is, I'm changing where this is pointing. So that should do the insert. All right, so how about 213? So this is a hash function. And it's one of the hash functions we talked about where we basically take the ASCII codes of each character in a string, we add them together. And in this case, we reduce modulo 31. And this should take a string and turn it into an integer between 0 and 30. So your function prototype is just hash, take a car pointer, return an int. And some samples, if you hash the character A has an ASCII code of 65, reduce it mod 31, that should give you a 3. If you hash the string ABC, it should give you a 12, and so on. And there's some samples. And I put a note in here because if you say fgets string and then try to hash string, and you type in an A, you're not going to get a 3, you're going to get a 13. And if you hash ABC like that, you're not going to get a 12, you're going to get a 22, because fgets puts a new line on the end of your input. And you're actually hashing A followed by a new line, which is ASCII character 10. Or ABC followed by a new line, which is ASCII character 10. So if you just say fgets and hash, your numbers are going to be off by 10. That's not a problem with your hash function. Okay, don't just subtract 10 from your hash function to try to fix that. Your hash function is fine. The difference is because you think you're hashing the string hello 5 characters, you're actually hashing a 6-character string. Hello followed by character 10. Yeah?
So in the hash function, would it be okay to loop until you reach the new line?
No. You gotta hash everything up through the null terminator. Because if you wanted to hash a book, it's gonna have a bunch of new lines. You don't want to stop at that point or ignore it or something. So the hash function should just blindly read each character, add the ASCII codes until it gets to a null terminator, and then it can stop.
So the 12 is remainder.
Say again?
The 12 is mod 1.
Yeah, so like 198 mod 31, that's the remainder when you divide by 31. Yeah. Now if you want to make a test program that lets you type in A, hit enter, and have it hash A instead of A new line, you can do something like this. Right, so your usual character string. And then your usual fgets. So practice code. Suppose you type in hello, and fgets puts a new line at the end. And we want to turn that into just hello. Okay, so we know there's a null terminator. And we want to basically change this into that. And we can do that by taking this null terminator and replacing it with a \0. So we got to figure out where the null terminator is. And we know it's the last character in the input. So HELLO new line \0. If I do string length, what is it going to return for this string? It's going to return a 6. String length counts everything up to, but not including the null terminator. Doesn't treat new lines as being anything different. Right, so 1, 2, 3, 4, 5, 6. If we want to replace that new line with a 0, what's the index in this character array of that new line? Yeah, so this is index 5, which looks like length -1. And you can try a couple of other test cases, and this will always turn out to work. So the kind of magic you can do here is something like this. So take the length of the string, subtract 1, set that character in your string equal to the null terminator. That basically overwrites the new line with a null terminator. effectively removes it.
Isn't there some sort of strip function that does that for you?
Oh, there's tons of functions. But Desert Island, this will work. All right, so if you were to do that in your own main program and then type in ABC and call your hash function, you'll get the values that are shown in that README. Or you can just call hash of quote A, call hash of quote ABC, call hash of quote hello, and see what it prints out. So all of that has nothing to do with hashing or hash functions. It's just oddities of doing input in C. All right, so clear on the goal here? All right, tomorrow's ODP is exactly the same, except it adds a second argument to the hash function, which is a probe. And I think I just add the square of the probe to the sum before you reduce. So it's like 5 extra characters or something. So get this one working, and 214 will be a slam dunk. All right, so I've opened quiz 2, which I would like you to do before Wednesday. I wonder if it gives you answers if I say preview. Okay, it doesn't. Good. All right, so hop onto Canvas. You can take this anytime you want before Wednesday. 5 questions, multiple choice. If you declare integer x bracket 32, how does the compiler treat the symbol x? Okay, so these are kind of week 1, week 2 questions that we've already been talking about and you've been working with. So think about these and ask questions if they're not clear. But I think this is just kind of like more refresh of what you've been doing. So that's quiz 2, and it's due, I don't think it'll tell me here. I think I made it like midnight Wednesday.
Maintain lockdown and the alternate. This is only a drill.
Is that all?
Yeah, they did announce that one last week.
Oh, okay.
You know the drill, right? So.
Campus computers, it turns on dot as
Yeah.
well, but not on your personal device.
Yeah.
So,
If I complain, they'll probably ban personal devices. So.
you don't use Clark devices, you don't get a warning.
Yeah, exactly. Live on the edge. All right. Yeah. So those can seem kind of pointless sometimes, but they're pretty important because you want reflexes basically to help you do what you need to do in situations. Okay, so Wednesday I am opening a new quiz, which is a GDB quiz, and it's either 5 or 10 questions that you need to go into GDB for, and there's a file on the server under /temp called G1, and you need to run GDB on it and do some things. So if you have avoided getting too far into GDB so far, this will be your excuse to jump in full force. But what I'd like to do on Wednesday is take a little bit of class time and have people work on this in class. And I'm going to let you work in groups. Okay, so if you have a laptop you can bring in, definitely bring it in on Wednesday. If you don't have a laptop or a usable tablet or something, then you'll want to work with somebody who does. And you can do the quiz at home. I'm going to leave it open for a few days, so you don't have to do it in here, but it's more instructive maybe to work with other people on this and kick around some ideas. So it takes a little bit of sort of sleuthing around, looking inside GDB, using different commands to figure out how things are organized in memory and so on. So Wednesday we'll put that up on the projector, and I'll have you get into groups and start working through that, and we can talk about it as a class and so on. So, and like I say, if you prefer, you can just do it at home also. But it's a chance to get it done in here. These quizzes aren't big deals. They're a few points each, but I want to make sure that that you're doing them. I think last year when I did this, I made them do like the last day of class, and guess what happened the last day of class? I got like millions of panicked students asking all these questions about every single quiz. So I'm putting due dates on them this time. All right, so we'll do that Wednesday. So hashes. Let's think about hashes as an abstract data type. So we've looked at the general view of hashes, what we're trying to do, storing data associated with some key. And we looked at hash functions, and we spec'd out some pseudocode related to doing things like insert and search and so on and so forth. But let's take a step up from a user perspective who wants to use a hash. What does our interface look like to a hash? Well, there's some kind of initialization function. So I might say something like hash table equals a init, or maybe a init hash table, but something that like sets up your original hash table. And then we want to be able to say add, and maybe we'd pass in a hash table, and then a key, and a data. So this says take this data and associate it with this key. And typically, if this key already exists in the hash table, what we're doing is replacing the data associated with that. If the key doesn't exist, then we're adding a new key and we're associating the data with it. So we want to be able to add, we want to be able to delete, and typically we'd say delete this particular key and its associated data from the hash. And we could say fetch and give it a key, and that would return some piece of data associated with that. And those are definitely a set of functions we want. We want to be able to add things to the hash, retrieve things from the hash, probably delete things. There's one other thing though that we need, and we've encountered this when we talked a little about associative arrays in Bash back in 2.24. We'd like to have a way to somehow go through the hash and get all the data one piece at a time. And with a regular array, we can write a for loop for I equals 0 to 100, get element I. For a linked list, we can start from the sentinel and we can just follow links from node to node until we get to the end. For a hash, there's no built-in way to do this. With what we've got up here, there's no way to say, show me everything that's in the hash. If we know that there's an array underneath and there's a valid flag and there's a deleted flag, we can write a for loop. But from the user perspective, all of those details are inaccessible to us. Okay, as an abstract data type, we don't want to have something that says, you know, for I equals 1 to 1,000, if element I dot valid equals 1, etc., etc. Those things are off limits to us. So how can we write some sort of function that the user, the main program, can use to retrieve all the stuff that's inside the hash? And the general approach would be something that we can call an iterator. And we'll talk about these a lot in 2.23. But the idea of an iterator is it does exactly what we're trying to do in this case. It's something that we can use, a function we can call that will basically give us all the stuff in our table, one piece at a time. So we might have another pair of functions called get first key. And another function called get next key. And you use these two functions together. So suppose you want to just dump out all the contents of your hash table. So we could say get first key, and it'll return a key to us. This will be the first key in our hash table. Now what does first mean? It's arbitrary. It's not necessarily the first key that we stored. It's not the first alphabetically, but it's a first key. And after we've called get first key, we can then call get next key again and again and again, and each time it'll return a new key to us. And presumably it'll return something like null, some kind of indicator when it's hit the end of the hash table. So if we wanted to dump out the whole contents of the hash, we could say key equals get first key. We could fetch the data associated with that and print it. Then we could do this and say, well, this is not null. Fetch the data associated with key, print it out. Yeah?
Would we have to give it another argument to say where we are currently, or would it store that?
There's different ways to do it. You might have something where you pass the key that you had last, or it might keep track of it internally. So I'm envisioning that it's keeping track of it internally, and it's initializing something when you call get first key. So with those 1, 2, 3, 4, 5, 6 functions, we've probably got a pretty complete interface to a hash table. So there's a package called DBM, Database Manager, and it's currently GDBM, that's the GNU version. And this is an implementation of a hash table in C, basically. And it lets us do all of these things, plus some other stuff. So you have to include an include file to set up some symbols for you, and you have to link with a -L GDBM. But then you have access to all of these functions. So we have an open function, which is kind of like our init. We have close, which undoes the open. And then we have basically store, fetch, and delete. So store is our add, fetch is our fetch, delete is our delete. If you want to store something, you pass it the database file, the key, and the data, and don't worry about the flag for now. If you want to fetch, you give it the database and the key that you're fetching from, and if you want to delete, same thing. And then there's this pair, first key, next key, that return a key. So this next key needs to know the previous key that you used. And this gives you an implementation of a hash. So let's look at some code. So this is just test code. So GDBM file is how we define a pointer to the database, basically. It's like file star, but it's GDBM _ file uppercase. Key and data, instead of being strings or integers or something like that, they're a special type of thing called a datum. Okay, so datum is a type deft somewhere in the include file. So key and data are these datum things, and I've got my usual temporary character buffers and an integer status. So let's create the database. So you make a call to GDBM open. So this is the name of the database, and it's going to create a file in my current directory named database, and that's what's going to store all the stuff in my hash. And then the rest of this is kind of boilerplate. This is like a block size, I think, so how big a chunk it uses in reading and writing. And then this is a bit mask, which says I want to read and I want to write, and if the file doesn't exist, I want you to create it. And that's the mode, so that's a change mode type argument, so read write for me and no access for anybody else. And this should give me a DB object, right, a GDBM file that I can use to do hash operations. So then there's some test code. So I print out a prompt, enter S to store, R to retrieve, D to dump. And then I read a line from the user, and I switch on the first character. This should look familiar if you've been writing PA1 or PA2. We just keep doing this stuff over and over again. So if you say I want to store some data, okay, it says enter the key, and I'm doing these F flushes to force it to print out what I'm printing since there's no new line. So it'll say enter the key, I'll read the key, and then I set up this key object, right? Remember, the key is a datum. So a datum has a pointer to the actual stuff, and then it has a field called size, which tells it how much stuff. This is minutia. Don't get bogged down on this. You're not going to be tested on this. So key D pointer is the buffer. D size, I set it to the length of my key plus 1 because I wanted to also store that null terminator. So that when I retrieve, I don't have to worry about adding a null terminator myself. So my key is basically the thing that I typed in. And then I do exactly the same thing for my data. It says enter data, and do an fgets, set up the data pointer and size. And then to actually store it, you just call GDBM store. So there's the database, there's the key and the data, and my flag is replace. If the key is already in there, just overwrite it. And we're done with the S command. If they say retrieve, again, I ask them for a key. I set up a key datum with the pointer and the size, and then I call fetch. That returns a datum called data, and if it returns a datum of length 0, that means it didn't find the key. So if the length is bigger than 0, I just go ahead and print out the D pointer as a string. Otherwise, I say the key is not found. And then D is using this iterator to dump all the keys. So call first key. So that's a first key. And as long as that's not null, I go ahead and I fetch the data associated with that, print it out, and then fetch the next key. And then at the end, I ask you to enter another command, and that's the end of the loop, and that's the whole program. And then we close it at the very end. So you need this -L GDBM to link in those routines, because these functions that I'm calling, I haven't written those, but they're not normally included because it's not like printf or scanf that you use all the time. So it's kind of like square root. You have to say -LM to include that library. So you say -L GDBM, that includes those routines. All right, so if I run this, let's store a key. So I don't know, what should we store here? So what should we say about Izad? His misspelled office is in 109. Nick, nope, store. Nick doesn't have an office. Store. Cupcakes are fun to make and eat. All right, so I'm just storing random stuff in here, right? And my key doesn't have to be just a name or something like that. This is a weird key with some strange data. All right, so I've got some stuff stored in my hash table right now. So I can say retrieve, and I can search for the key Nick, and there's what was stored associated with Nick. If I say retrieve cupcakes, right, there's what's stored with cupcakes. If I say retrieve haha, it tells me key's not found. And if I say D, it shows me everything that's in my hash table. So there's Nick, there's this is a weird key, there's Izad, and there's cupcakes. So I can quit out of this, and there's a file in here called database, and it's gibberish to us. But if I run my main program again and I say retrieve Izad, right, his information is still in there. And if I say dump, all the information is still in there, but I can add to it, or I could replace, and so on. So this is like a little mini database. It's not like a relational database, but it's a way to dump information into this hash table, pull it back, and it's persistent, which is kind of nice. How many people here play Rogue? Oh man. You're far enough along you can afford to get distracted. So yeah, so Rogue is on so Rogue is on the Linux server, and it's GUI based adventure game. So you're moving around a dungeon and you move with HJKL, same commands you use in VI, and you get chased by creatures so you can fight the hobgoblin and defeat it, and so on and so forth. You can pick up gold and all sorts of good stuff, and there's hidden passages. And I was hoping I would die really soon. Jackal. Come on. Snakes usually kill me on level 1. I won't fight it, I'll just hang out here and let it bite me until I die. There you go, so I was killed by a snake with 12 gold. So when you're done, it shows you a list of the high scores. And I think these are old scores, so you gotta like beat these. But you could store this in, you know, a GDBM type hash table, right? You just make a hash file, and you could have a username, and associated with them could be, you know, how they were killed, and their score when they died, and what level they were at, and so on and so forth. And it would be sitting in a file, and you could pull that out anytime that you want and update it, and so on and so forth. All right, so GDBM is useful. So when I was dusting off some of this stuff to put a lecture together, I discovered that GDBM was not installed on my machine by default. So I downloaded it, and it comes as a tar.gz file, and you have to build it and install it yourself. And this is typical of what you do when you download software. You can download packages sometimes and it does everything, but if you actually want to, like, you know, install a driver or something like that, you typically get a tarball, a tar.gz, it's called a tarball, and you have to kind of work from there. So let me just kind of run through this really briefly. So I've got my tar.gz. I'm going to make a directory. I'm just going to call it source, and I'm going to do everything in that directory. And the first thing I'm going to do is do a tar extract on that tarball. So remember, xvf says extract, be verbose, and here's the file name I want to extract from. And it'll give me a bunch of output. It tells me it's created all these files. And they're all sitting under a subdirectory, gdbm 1-18. So I can go into that directory, and I've got stuff. Now I've got some Makefile-ish looking things, but I don't actually have a Makefile. And there's a source directory, and it's got all the C code for GDBM. There's a hash.c. And this is, you know, the hash function that it's using to figure out where to store. And there's lots of magic numbers and hex codes and things like that. But this is all source code, right? It's 15,800 lines of C code that creates this GDBM. And you know, you can modify this. This is sitting in my directory. This is my copy of this. I could tweak the heck out of this and make my own variant of it, right? That's part of the idea of open source. And you know C, and you know about hashes, so you could like make this better, you know, stronger, faster. Or we can just build it exactly the way it is, right? So let's do that. So I'll go back up into this area. And usually, if you don't have a Makefile, what you need to do first is what's called a configure step. Because when we do a Makefile, you're doing it on the Linux server, I'm building it on the Linux server, I'm testing it on the Linux server, everything's working in the same environment. So I know what GCC does, I know what version of GCC we're using, and so on. If you're making a project that's going out to the entire planet, and you know, one person's going to be building it on the Raspberry Pi, somebody else is on a supercomputer, there's different environments. So configure usually goes through the system and looks what version of GCC, what version of Bison, and all this other stuff. And configure is, in this case, 17,000 lines of shell script. And you just kind of cross your fingers and hope that it works. And you obviously got to trust your source because you're about to run a shell script with 17,000 lines in it. And if it's going to install a rootkit or something, you know. So
It might have an RM star.
it might have just an RM star in the front, yeah. So, but I'm the trusting sort, so I'll just go ahead and run configure. And I don't know what any of this stuff means, but I didn't get any error messages. And so presumably that was good. And lo and behold, now there's a Makefile. And it's a big Makefile. It's 917 lines. So it's a little more involved than what we've been doing. But it's the same idea. It sets up some functions, and it does crazy stuff. But lots of regular expressions and lots of symbols and loops, and you get the idea, right? So you cross your fingers and you say make. And you can see it's compiling a bunch of stuff. And CC is a symbol set up to something. And no error messages, which is good. And if I look inside source, there's all my .os and some .los. And so first you do configure, or sometimes it's make config, and then you say make, and that usually creates everything that you need, and then you have to do one more step usually, which is make install, which actually copies stuff into the system areas where they're accessible. And if I just say make install here, I get an error. And the error it gives me is, you know, cannot remove, permission denied, things like that. Because I'm trying to install into the system areas on this machine, and by default, my user ID can't do that. So you do sudo, which says run this as a super user, and it goes ahead, no errors, and now GDBM is installed. And that's where you get things like the manual page, and being able to say -l GDBM, and being able to say include angle bracket GDBM.h, and so on. And that's just a very typical tool flow for installing software. Right, so you download, you untar, you configure, you make, then you make install. But like I say, don't do it unless you trust your source. And again, usually when you download this, there'll be something like, you know, an MD5 hash or something that you can use to help authenticate that the thing that you've got in the tar file is the one that you're supposed to be using, and it wasn't replaced by something. All right, questions about that? Like I said, I'm not going to ask you questions about using GDBM on tests and stuff, but I want you to know it exists, and it's installed on a Linux server, and if you're interested in messing with it, right, that's a good place to start. This little test code of mine, I'll go ahead and post that on the website that you can get to from Canvas, just as a starting point if you want to play around with this stuff. All right, so bring questions tomorrow, otherwise we're going to move on and we're going to start talking about stacks and queues.